first one is from Jereon Vandeleur, and following up to his talk from last year, he will tell us a bit about how to automate purple teaming tasks.
Thank you very much. So yeah, I always make the joke, typically when I'm over in the United States, but so my parents, they have, my father, they have like a very Dutch last name, Vandeleur. And then they even gave me a more Dutch name called Jeroen. So sorry for that. But actually, it's my parents' fault, so no worries about that one. So yeah, we're here, the diehards, actually, because I just mentioned it. Like, if you do this in Belgium, you know where Belgium stands for? Like the most important export products, like chocolate, and on the other hand, beer. If you do it on a Friday evening in Belgium at 8, on a Friday, I'm afraid nobody will show up because everybody's drinking beer there. So welcome everyone. So glad that we have an audience here. And I'm indeed going to talk about the always-on purple team, an automated CI/CD for detection engineering. So who am I? I'm Jeroen Vandeleur. I'm working now 13 years for NVISO, actually first employee of NVISO. Maybe you saw already like the little bird logo on the electric power plant from Verbund. So that was a project we were working on together, which was a very nice and a very nice and challenging project. So within NVISO, my role is technology lead for NVISO Labs. So together with all the teams, I'm looking how we can innovate, how we can actually use technology, and how we can make our services more efficient and more effective. Now, next to that, I'm also a SANS instructor and author for a course called SEC 598, which is security automation. And that's also something we tested out during this presentation on how we can actually automate like detection engineering. So what are we going to talk about? Well, first of all, anybody of you experienced with purple teaming? You can just raise your hands, then nobody? Okay, so we have a small introduction, so I can explain it. It's combining red and blue, and then you get purple, so that's easy. So then we also have a problem statement, so how can we improve our security monitoring, our security operations with AI, so with artificial intelligence? How can it help? How can we actually get support from, for example, I already saw it a couple of times, ChatGTP, but that's also an example we are using here. Then we have, and I do have to admit that that title is not that good for me, maybe personally, but we have detection engineering on steroids. And then we have questions and LLM-generated answers. All joking aside, if there are questions, I'm happy to do it manually. So let's start with the beginning and have an introduction to purple teaming. So if you don't know what purple teaming is, if you don't know what red teaming is or blue teaming, well, actually, we used to have penetration testing. Penetration testing was limited in scope. We had a certain application or a certain system or a certain challenge that we need to solve there by penetrating, by doing offensive tasks onto that environment. So really like penetrating an environment where you were actually coming in from an attacker perspective. But there, the scope was very limited. In that sense, typically, it was also announced, and in most cases, it was just based on, we need to do a pen test, because otherwise we cannot go to production. So it was just like a check mark, okay, we did a pen test, and typically, when you did a pen test, you also saw that certain systems were not reachable anymore. So that's, of course, when you announce it, and there are some weaker services, typically, they tried to hide them or they tried to filter them out. Now, in that perspective, red teaming started to exist, and red teaming is a broader scope. So within a red team, we are actually using a scenario where we are going to try, attack, and simulate a certain adversary onto an organization. So again, it's from an offensive side. The blue team, which we call typically the blue team, are more the detection people. So you're, like you have these days, a SOC, Security Operations Center. Those are typically more the blue team people or blue team engineers there. So red versus blue, if you compared both, so first of all, red teaming is really stealth, so normally they don't announce that a red team is coming, so Also, there is no change in scope there. There are no systems that are magically going down or not existing anymore. What we also see in red teaming is there is no real collaboration between red and the blue team. So the red team is going to do their attacks, and the blue team is going to see some things happening there, but they don't know what's going on there. And it's really, and that's the main point there, it's focused on an assessment. It's a snapshot at that point of time, and it's really focused on an assessment to really get like the security risk within your environment. Now, if we combine those tools, and we see that that approach is more and more being leveraged these days, we have purple teaming. So that's really combining red and blue together, meaning the red team informs the blue team, okay, we think these and these and these scenarios are good for your environment, so we want to test them out. And the blue team also gives input, like we have these controls in place, so probably we should detect this, or this cannot work in our environment. So you have a much more focused assessment there, and you actually have collaboration between the two. So there's no stealth, there is collaboration, so they are actually working together. Why? Because they have the same common goal. They want to improve the security posture. So there the focus is really on improving, and not on having an assessment, having all those findings, and then actually have some high-level recommendations there. So that's why we see purple teaming being more and more and more used. That doesn't mean that red teaming is not interesting, that the red teaming is not being done anymore, but it's just a different approach. Purple teaming is more in a continuous manner, and red teaming is typically on a snapshot perspective. So if we then see a little bit, go back to the presentation we did last year. So this is actually an overview that we created, and you can check out, I still believe it's online there, so the previous presentation. So this was really focused about detection. So we are executing certain attacks, and we want to know, do we detect them in an automated manner? So again, you have the red part, which is actually executing the attacks, and you have a blue team, which is detecting the attacks. Now, in this case, it's technology that is executing those attacks in an automated manner, and it's detection, like, for example, an EDR tool or an antivirus maybe, or a SIEM tool that is generating those detection. And based on a single platform, we are able to tell, we executed this, and we detected that. So this is an example of how a dashboard in a SOAR tool in this case, so this is an example, you can do it actually with any SOAR tool, but this is just an example on how you can concatenate both and then see, like this is the overview I have from my executed attack chains, so it's actually here on the top. Then you also see an overview of all the techniques that are being executed, and then you have, in summary, what you are already detecting. Also, the relevant detection use cases are being, then actually showed as an output. Anybody has experience with MITRE ATT&CK or knows what MITRE ATT&CK is? A couple of you, perfect. So MITRE ATT&CK is just a collection, it's actually a database or a collection of TTPs, which typically are being used by adversaries. So emulating a certain scenario of an adversary, of a known adversary, you can easily find those attack groups, those campaigns, you can easily find them in MITRE ATT&CK, and there actually see which kind of techniques an attacker is using to penetrate your environment. So this is also based on those techniques. Now, of course, detection is silver, but improvement is gold. So it's nice to have that dashboard, definitely. It was already nice that we were able to establish that. But we also want to improve, of course. And improvement typically was a manual thing. So as you see here, there's a detection engineer. He says, okay, I see that technique 1003.001. Anybody knows which technique that is? Anybody with MITRE ATT&CK experience? It's credential dumping from Alsace. So it's one of the commonly used attack techniques. So what is it actually doing? It's, for example, in Alsace, in that process, it's caching your credentials there. And if you don't have, for example, something like Credential Guard, an attacker is able to even read credentials in clear text if they were cached. So in this perspective, an attacker, or we executed that technique, and our detection engineer says, but I know there are some rules for that to actually detect it, so why don't I implement them? So he knows, okay, there are some Sigma rules. He knows also that he's working with Azure Sentinel, which is a SIEM, and then he actually is going to test and deploy that new detection rule, and then he's going to run that technique again to see if the detection rule is working. Now, this is like a manual process at the moment, meaning there are a bunch of steps that need to be done before he can actually implement that technique. So maybe, not the detection dashboard there, but maybe there's an easier method. So for a programmer, this indeed takes maybe 5 minutes, but maybe ChatGTP can help. So let's ask that question to ChatGTP. So can vanilla ChatGTP generate detection rules? Well, actually, that's the conclusion, not bad. Why? Because the rule as such is well written. So the proposed detection logic is good. What does that technique, so dumping credentials from memory from LSAS, what does it do? Well, it generates an event accessing that process and actually grabbing the credentials. So you see here as well, it's a security event where the event ID type is 10, which typically means that it's accessing a process. And there we also put an additional where on top of it, saying, okay, if the destination is LSAS, then it's probably credential dumping. So the logic behind it is good. Proposed format is also good. Only problem is a lot of those processes are accessing LSAS, not only for credential dumping. So we will have a lot of false positives here. So in this case, yes, it can work, but it needs some fine-tuning. So how can we do that fine-tuning? Well, there we have like an entire architecture that is going to do the logic for us. So in the previous presentation, there was no middle section called LLM. So large language models, as we know. So LLM, what are we going to do here, or what are we going to showcase? Because I have 2 demos, and they are, I cannot do them live because it's cloud-based detection. So that means also sometimes we need to wait for 10 minutes for an alert. And if I have a presentation of 30 minutes, that's not going to go well. So in that perspective, we recorded, and we even speed up some of the recordings there just to fit it in this half hour. But what are we going to do? And this is maybe important that you have the overview. We have a test system where we are going to execute attacks. So we are really going to execute those attacks. And those attacks are being executed by a BAS tool. A BAS means breach and attack simulation. That really is like, for example, you have commercial versions, but Atomic Red Team, you can also, it's an open source project, you can also install that on your test team to simulate those techniques. So from an attacker perspective, you are simulating, for example, credential dumping on that test system. Now, what we also have on the test system is logs. We want to ingest those logs to see, okay, what are we detecting? Are we actually detecting that we are accessing LSAS or not? And that's being forwarded towards a centralized system where we have those detection logic use cases. So that's also where you want to improve. If you are not detecting anything, that's actually where you want to improve to see, okay, how can we detect newer attacks, newer techniques? And everything is being managed there from a SOAR perspective. So SOAR stands for Security, Orchestration, Automation, and Response. In essence, it's like a large automation framework where you can integrate with multiple components. And it's the central brain in this perspective because it's going to know which attacks we are executing, but also which events and which detections we have. Based on that, if we see that a rule or a certain technique is undetected, we are going to, like I showed you with the plain vanilla ChatGTP example, we are going to try and ask for support to a large language model to generate or to propose a certain query. if we fine-tune it and validate that query, we can actually deploy it, and we can run the cycle over again to see, do we now detect that technique. So I hope this is clear, but it's really like a continuous loop where you have like your detections, and again you start your attacks, your detections and your attacks, and you always try to improve and upgrade or improve your detection ratio there. If it's not clear now, you will see it in the demo how it works. So the first step we need to do, anybody ever played around with Caldera? A couple of you, perfect. So Caldera, great tool, it's open source. I'm a big fan of Caldera. The first version, I was not such a big fan of Caldera because it had a lot of bugs in it. But nowadays, the newest version is really well maintained, and there are still some bugs running around in that open source application. But it's really like an adversary emulation tool where you can say, I want to run these techniques in a chronological order, and you can even extract the output as an input for your next step. It's really like an attacker is working. So for example, he dumps credentials from memory, he takes those credentials, and he will use those credentials in a next step, maybe to go to another system. You can easily automate that with Caldera, for example, because those techniques are in there. So Caldera, it's basically a collection of different TTPs that will be executed. So a Caldera adversary. Now, it's really like terminology of Caldera, but to be honest, it's pretty straightforward once you are playing around with it. So we have our adversary, so we know, okay, this is what we want to simulate. Of course, you want to run that operation, not in Caldera itself, but you want to instruct that operation from within your centralized platform, in our case, our SOAR tool. So here you can see that we will invoke like that adversary within our SOAR tool. Then you're going to, of course, review those detections and see what is coming out of my detection rules, and if it's really out of the box that it's already being detected, or you need to adapt your detection rules there. So typically, yeah, certain basic scenarios like group discovery, local groups, when you're accessing, for example, the local administrators, that's going to be triggered. For example, Defender for Endpoint, it knows, okay, that's something weird, maybe I should monitor that, so there is already a detection rule in place. And you can see that over there. But you also see that there are other techniques not being detected. That's by the false that you see in the detected column, of course. Sounds logical, but it's Friday, so in any case. So once you reviewed that detection rule, we actually are going to see why we didn't detect certain other techniques. So how can we generate detection alert logic? Well, we are actually wrote like a plugin with ChatGTP there, and we have implemented a dynamic prompt generation mechanism, which is just like a structured question that we are going to ask towards an LLM model to say, okay, can you generate a detection rule based on this? So as you can see, it's 5,000 years of accumulated human knowledge and know-how in one specific tool. There is ChatGTP again. But you can also do it with other models. So, and Microsoft itself, in this case, Sentinel is Microsoft, so it's based in Azure. Microsoft itself, they are also continuously evolving related to AI. So once you have generated that logic, don't immediately deploy it to production, because there will be errors. So you need to validate and fine-tune that detection rule logic. So what did we do here? Well, once that query is generated, we are going to test it. We are going to test it against the data we already had. So here you see, initially, your detection rule was generated by ChatGTP. We imported the detection rule, and we see that the query result gives an error. So meaning the syntax was not right. And that's indeed true, because the table that it was requesting doesn't exist. So that we need to adapt. Of course, what can you do with the error you get? You can throw it back again to ChatGTP and you say, hey, your query is not working. This is the error I'm getting. And it will actually automagically solve it. Not always, but in most cases it will solve it. So we get an improved detection rule. We see now that the detection rule is returning 29 rules. So meaning we see now we have a detection mechanism. In our logs, there are 29 references towards that case, towards that specific detection. And we also have like a summary, like, okay, if you have like 100 detections in one day, then probably you don't want to implement it because it will generate a lot of false positives. So zooming in on the queries that we use, just a small example, these were the queries. So you see it's fairly simple, but we are using some dynamic values. We have a query to generate the initial detection rule, analyze and attempt to fix the errors. Again, it's a standardized query. And then to see if it's accurate enough, if this is a good or an accurate detection rule. So let's see it now in practice. So this is like the main interface. Oh, new. So that should be automated. Yes. So this is like the main interface. In our case, it's XOR, but you can use whatever automation and orchestration tool that actually is out there. So we are going to create a new Caldera operation as an incident. We couldn't change the XOR interface because everything in XOR is an incident. But here, the operation that I showed you, like the list of techniques that we are going to execute, is here being created as an incident. So we put in some values there related to what we are going to execute. And now you see that the incident is generated, and it's in the backend, it's going to call Caldera and actually start the execution, start the operation, do all those techniques on my test system. You see the status there, it's running. You also see an overview of the techniques that are being executed. And there you already see, like last year, the operation detection rate. So how many of those techniques are we detecting? You also have some additional information related to the techniques, which status they have, if they were detected or not. So here you really see the same output that you have in Caldera, but it's actually transferred towards our SOAR platform. So those are the operational details, and then we need to wait until all the detections are coming in. And you see here we have 2 detections, so 2 out of the 7 techniques are being detected, which is initially already a result. Is it good, is it bad, depending on your maturity, but in certain cases it's already good. So here you see the operational details. You see that those techniques were being discovered, and you also have the incident that was linked towards that technique. So now we want to create like a new rule, so review and customize detection engineering. So create, based on the techniques, we can select here. So here you can really select, okay, what is the table where those detections should be in? So this is like something specific for Sentinel, but typically all detections are in the security event table. And then you can also select, that's really like take into account the command that is being used. So, and then we of course also need to select, is it now? Oh, okay, it's still working, perfect. Then you also need to select the techniques there. So here you have all the techniques that we executed. So again, the list of Caldera is in there. And there you select all of those techniques. And you just say, okay, run that query. And then it will generate like an SQL query. There, for testing purposes, you can also set dynamically a range where you say, okay, if you run that query, you need to review it over the past 30 days. So in the backend, there's an automation playbook. This is the automation playbook. So we get the undetected techniques. We want to combine those techniques, and then we are going to loop over all those techniques the same questions, again, towards ChatGPT, like give me a detection rule for those techniques. And here you see the output. So in the first case, there's a true, but the query result is 0, so we don't have any entries in our table related to that query. But you also see that, in certain cases, you have like a command line error, so it wasn't a very good rule there. So what you could do is manually edit it, or you can actually copy-paste the output and say, improve that query. In this case, we are going to manually edit. Reasoning why it didn't work is because our LLM set starts with, and it actually needs to be contains, which is like a stupid mistake, but in this case an important one, because it needs to contains these two values somewhere in that command line. And once we run it again, we validate the query, then we see that we have that we have actually 7 query results there. So now it's working fine. So we can now deploy it towards our production Sentinel, and we can do it over and over again. So here we are going to just, those queries that we just made, based on the ChatGTP queries, we can now deploy them, and then it's just rerunning the entire campaign again. So from that perspective, once those new detection rules are being deployed, you will have a better and more accurate visibility related to the techniques you are executing. So here you see a little bit the overall overview that is then actually being detected more, and there you see what is being deployed onto Sentinel and which techniques it's covering. So there, now if we rerun the campaign, normally we should have, instead of 2 out of 7, we should have more detections. So we have 5 Sentinel rules that are being deployed, so 5 detection use cases that were being deployed. And then we re-execute the operation, and then we actually have, again, a running campaign, and in the end, you should see that we have detected more techniques there, thanks to our detection rules that were based on the provided information by ChatGTP. So from 2 out of 7, we go to 5 out of 7, which is a nice result in a couple of minutes. Now, preliminary conclusions. So I think, there, atomic TTP. So are we going to replace humans? No, not really, because pen testing, red teamers, blue teamers, there still needs to be human intervention. There still needs to be human logic behind it. It also is, it can be used for automation. How? If you have those techniques like really structured, and that you can automate them over and over and over again. So that's why, for example, the MITRE ATT&CK database, which is a small chunk of techniques there, which actually presents a small code of that technique, if you can reiterate them again, you can actually automate it then. So TTP should be continuously tested automatically. That's definitely something that can be done. LLM models can be a force multiplier for detection engineering. So they do suggestions and they support your detection engineering, but you also need to fine-tune them. So that's actually the last conclusion there. So detection engineering, oversight, and fine-tuning, it is required for the optimal output to actually have the detection engineering. Now you will see there's a second follow-up on this demo related to RAG and related to agents, AI agents, where we even are trying to automate more. I see that I still have 18 seconds left, so I'm not going to go over that entire demo. But that's actually also our third build in this presentation, where we have Crew AI, definitely something worth looking up. So if you have heard of Crew AI, it's like a Python framework where you can create offline agents that are working together with all those things, and which actually is a very, very nice project. So with that, I think I'm at the end of my time, so I will quickly go to the question slide. So are there any questions? Yes.
Thank you very much. What would be the manual task needed to set this up?
The manual task needed, so the integration with all those tools, that's definitely something that you need to do manually, so that all those tools are talking together. So typically it's API, REST-based AI, so REST-based APIs that you are sharing information, so collecting input, collecting output, And installing, now to be honest, that also you can do it with Terraform infrastructure as code. You can have this all templated. So then you deploy it like in a couple of minutes, to be honest, in a cloud environment, for example. But typically, yeah, the initial setup, I think we did it with everything combined, we did it in 2 man days or something to set it up. Like it's pretty, depending on the technology you are choosing, it's pretty straightforward to set up. But it needs to have some kind of interaction, APIs, and if you have a well-documented Swagger file, for example, it's easily set up.
Do you have any dependencies on the CM side? Or
Well, yeah, the dependency here is on the SIEM side. In that sense, we are using Azure Sentinel, so we're translating everything in KQL, which is syntax for Sentinel. So only dependency that you then can you can take it to a higher level and say, don't use KQL, but use any of these models or any of these syntaxes. Any other questions? Then I want to thank you for staying, and enjoy the Friday evening and the last talk.